In 1967, Larry Roberts, researcher at MIT, proposed what would later become the forerunner to the modern internet. ARPANET was designed to connect the military ecosystem together in robust and resilient ways to ensure communication could continue in the event of nuclear war. It crossed into civilian life and met humanity's timeline when programmable computers were just starting to run the code that they themselves had programmed on the same hardware. Before that, paper tape and punch cards stacked perforated card into program packs that represented the whole program and would be sent somewhere else to be loaded and run on mainframe systems on a first-come, first-served basis. It was a hugely inequitable process where card packs sent by international researchers without access to their own mainframes traveled hundreds or even thousands of miles to wait at the back of the queue. Programs would take several hours or even days to run, and the results would be printed out and sent back by post. As you can imagine, if you didn't have a local mainframe to you, debugging took a very long time. Some international researchers even conceived and had children before they got the results back. Now today, microcomputer networks are the backbone of a completely transformed human experience. Server-side software for every smart device, mobile app, connected health device, or even IoT smart bins runs on conceptually the same microcomputer architecture from the 1980s. But as a climate-concerned engineer, applied mathematician and technologist, what interests me is not really the sexy new AI or having all of the world's information on my wrist. It's the resilience that these decentralized, horizontally scalable systems provide. Because these are inspiring systems often seen in nature that can teach us humans a lot about creating adaptive, functioning infrastructure in our own societies. Now, we live at a time of converging disasters. World War is closer now than at any time since the 1930s. At the same time, anthropogenic climate change has disrupted Earth's delicate balance, which scientists concede what many of us mathematicians have known for a while, and that is happening faster than expected. And it is here that we find such an unlikely anti-hero in our story. Plastics. Now, every year, the world throws away 340 million tons of plastic every single year. 8 million tons of that makes its way uncontrollably into waterways and oceans through uncontrolled dumping and leaking from exports. And it's not just the plastic pollution itself. It's the nearly 45 billion tons of CO2 emitted across its entire lifetime, from extracting the oil and refining it into petrol to turning it into plastics, transforming it, moving it, and ultimately disposing of it. Harmful plastic has earned its criticism in many other ways. Impossible single-use fantasies take natural resources, turn them into something unnatural, throw it back at nature, and expect it to deal with it in an intractable form and a suffocating scale. Extracting resources of any type causes ecological injury, and both dumping and incineration compound that damage wherever you use it. Now, only 9% of the plastics ever made have been recycled. There is now enough plastic that every human on Earth can take ownership of a whole ton of this stuff, put it in their garage if they wanted to, and there'd still be plenty more to share. But the emissions footprint of processing this material is often 10 times the mass of the material itself. Discarding it grossly disrespects and harms not only the planet, but also the world's poorest communities who depend on it most, who carry the health burden of poor air quality and poisoned land. And even worse, this material that humans burn or landfill or even export still has plenty of intrinsic value. Take these medical plastics, for example. These are higher quality than those used to make cheap commodity products like coat hooks or doorstops, even after they've been recycled twice. But legally, we can only ever use them once before they have to be disposed of. Yet they travel only a fraction of the distance of the other low-risk commodity plastics. So each time it's prematurely destroyed, humans demand an extraction of more. And that means more harmful actions against Earth, and sometimes with materials that are worse than plastics are. But currently, material recovery is actually really fragile. It must walk a tightrope of feeding fast while keeping quality. But a wrongly placed plastic bag can stop a city's worth of trash, which piles up outside while the systems inside the processing facilities grind to a halt. And that's because, like the half-job computers did in the 1960s, the recyclers don't manufacture and the manufacturers don't recycle, leading to very similar avoidable problems of scale, meaning more incineration, more landfill, more secondary waste, and more replacement material to be extracted, with all the emissions that entails. But just as programming and execution of machine code converged at this nexus of decentralization and hyperscale computing to democratize access to information, we can take inspiration from that to design the sustainable systems of the future that are more resilient by looking at nature, because nature already has these answers. Now, circular economies are a solution which looks great on paper. It diverts material from landfill into recycling facilities and then manufacturing instead, retaining in a virtuous loop the value of that material, while it recycles mercilessly to create a bottle out of a bottle and a bag out of a bag. And circular economies aren't just recycling. They actually force us to recognize what's actually truly waste, as opposed to what we can repair, refurbish, and resend. So what's not to like? It's that the implementation of circular economies for plastics have been naive at best. It assumes unrealistically pure feedstocks, or imaginary manufacturing that can take anything, and also that somehow material is teleported without any transportation between the parties. But since diesel transport can't be made carbon neutral, it's slowly dawning on people that the entire supply chain it lives within, up and downstream of the consumers, can also never be made carbon neutral either. It needs system change to make that happen. Also, this uneven transportation impact means the bottle becoming another bottle may actually not be the most optimal use of that resource. When the waste material is made locally and then transformed into something that you would normally buy from thousands of miles away, then actually that's a better option. It solves multiple problems at once, really quite easily. And this is what helical economies try to do. They don't attempt to turn a bottle into the bottle. They look at adjacent industries to move the material as products into there. And this can optimize beyond circular economies by between 40 and 80%. And this was always the case on paper. But a lot of ignorance to that method has garnered a mistaken criticism of downcycling, when actually it's perfectly fine for those other industries. The realization I came to 4 years ago was that shoehorning yet another siloed solution into the existing take, make, waste economy and expecting magic to happen is a bit of a mistake. Because ecologically, it's also but sociologically, it's also the method that's easiest to sell. Playing it to a crowd of the status quo that collectively harms through intent or ignorance. It can move and shift the blame at a time where the planet wants nothing but change. Now, we had to start entirely from scratch and make it happen fast. So instead, I created what we call circular microeconomies, which are all in one district-sized clusters, to take all of the relevant bits of circular economies, put them all together, remove the bits we don't need to use anymore, duplicate and clone those things into clusters, and then network them together so that communities themselves can drive a resource agenda by their own supply needs. We combined our mechanical micro-recycling hubs with our additive manufacturing 3D print vending machines to create these clusters. And that duplicates the scale of city-wide recycling, but for only 10% of the cost when used together, while also manufacturing the products that would otherwise have to be made somewhere else. Now, whether that's stationery for schools, DIY products for the home, or even accessories for the bike, everything happens in this one place, which is the first or final mile of the users themselves, without the intermediate transport in between. Now, better still, decentralizing it into distributed microeconomies also keeps the financial value that would otherwise be split up across multiple economic sectors, turning plastic trash that at best you'd get £300 a tonne for into over £75,000 worth of value because you're selling it now as the end product. And we do this while reducing emissions by over 9 times the mass of the material, keeping the cycle tight and removing unnecessary processing, which otherwise generates yet more waste. These clusters create jobs that have a better affinity with existing communities because they come from those existing communities. Yet the network itself can change shape in an afternoon if needs be to respond to danger or to chase opportunity, reorganizing often to bypass threats like geopolitical instability, climate change, and even war. This model is equally at home mitigating climate change, but also helping climate-adapted communities, whether that's in cities, townships, and even on the move. The whole thing can run on renewables, plastic trash, and human ingenuity. And like many solutions, it's here, now, being used. So just as programming and execution run as one system, we must think of the whole material stream as one system so that we can turn off the tap at one end and clean up the mess we've made at the other. And in a nod to ARPANET's legacy, it can be done robustly at scale without total system collapse. And at its heart, it stems from a need for both resilience and adaptability. The same needs ARPANET addressed 60 years ago, which we must now address again, and probably for 60 years hence. Both for people and for planet, sure. And with that, I'd like to stop talking rubbish, but to thank you for listening, and crucially, perhaps, to thank Larry for inspiring the idea in the first place. Thank you very much.